Hello, my name is Steve Burt. I'm the team lead for the Economic and Policy Assessment Group at the Institute for Transportation Research and Education at North Carolina State University. I will be providing a demonstration of the cost tool that we developed as part of NCDOT Research Project 2020-44, with the goal to better estimate the comprehensive costs of rail incidents in North Carolina. The cost tool accompanies a research report, a comprehensive cost of rail incidents in North Carolina. The report documents the methodologies used to appraise the various cost elements that are born from railroad incidents. In addition, the report provides an estimate of railroad costs over the last decade in North Carolina, with a detailed accounting of costs for year 2019. The cost tool that I will be demonstrating was used to estimate the values found in this report. I will be demonstrating how to estimate injury and fatality, also known as casualty, costs resulting from rail incidents. Injuries and fatalities have costs that accrue when an individual is injured or fatality occurs as a result of a railroad incident. An analysis of FRA casualty records in conjunction with the appraisal methodology recommended within the U.S. Department of Transportation's benefit cost analysis guidance was used to monetize casualty costs resulting from rail events in North Carolina. U.S. DOT recommended values for monetizing reductions in injuries are based on the maximum abbreviated injury scale, MACE, and are available in the cost tool. The MACE scale categorizes injuries along a 6-point scale from minor to not survivable. The project team recognizes that accident data are often reported using the CAPCO scale, which is a measure of the observed severity of a victim's functional injury at the crash scene. The cost tool also offers the ability to estimate injury and fatality costs based on this scale. Now that you've been briefed on railroad casualty incidents, let's demonstrate how the tool works. Injury and fatality costs can be estimated in Part 2, or the part of the tool designated in green coloration. Casualties can be entered using the maximum abbreviated injury scale, MACE, or the CABCO scale. For incidents that result in human injury with the level of severity unknown, it is recommended to use row 2J, or the CABCO U designation. Let's try it out. Let's imagine that we have received information about a rail incident. The incident has been with a rail collision involving a passenger train containing 8 individuals. We learned that there were 2 severe injuries, 1 critical injury, and we do not know the injury status of 5 other individuals. We can take that information and input that into the tool to determine the costs associated with those injuries. So 1 critical injury. 2 severe injuries. And we do not know the injury status of 5 other individuals. For this estimate, I would also like to account for the loss of productivity resulting from the number of workdays missed. This is a result of individuals being injured and having to take time off. I can use the injuries work missed worksheet to account for this. You can navigate directly to the injuries work missed tab at the bottom of the workbook. Or you can use the blue shortcut. Now let's make an estimate of the cost associated with workdays missed. Since we cannot see into the future, we're going to use expected values to project the number of days people will miss. If you remember, we had 1 critical injury, 2 severe injuries, and 5 with status unknown. We're going to use this information to cluster our estimate. We do not know the occupations of individuals, so we're going to use the all occupations choice. Similarly, we do not know the wage rate of these individuals, so we're going to use the median rate. Now for days missed, we are going to use benchmark values and context to make our estimates. So we're going to scroll to the right to see our benchmark values for days of work missed. Table A, the dark green table, shows the expected value of missing a day of work. These include instances where 0 days of work missed are included in the table. Table B shows the expected values of missing a day of work, the light green. However, instances of 0 days of work missed are excluded from this table. In this instance, since we know that the train incident resulted in critical and severe injuries, as well as status unknown, we will be using both tables. Table B is better suited for benchmarking when we know that there is an injury that has occurred and that an individual will be likely missing work. Table A is better suited for benchmarking when we don't know injury status and we don't know if days of work will occur. Starting with the critical injury, we're going to assume that that individual falls within the 90th percentile of days work missed. Then moving to the severe injuries, we're going to assume that those injuries are associated with the 75th percentile of days work missed. Finally, with the 5 individuals who we do not know about their level of severity, we're going to use the median days of work missed in Table A. For critical, Table B, 90th percentile. For too severe, Table B, 75th percentile. And for unknown, Table A, median. You can navigate back to the main worksheet. And we now see that the days of work missed have been included.